So welcome to the first King's Climate and Sustainability and King's Institute of Artificial Intelligence seminar that we're doing. And this event is called AI and Waste, and it's around tackling social and environmental challenges. And this collaboration really is great because it allows us to explore the interconnection. It really explores how waste created by new technologies can be detrimental socially and environmentally, but also how AI can be leveraged to address both of these dimensions of waste. And I'll soon hand over to today's chair and speakers. But before that, I just wanted to remind you of a couple of things. We've kept everyone's mics off, but please do try and keep muted just to avoid any echo and kind of reverberating while we do this. If you'd like to ask a question, please put it in the chat or you can put it in the Q&A section. We'll wait till the end of the session to start a bit more of a discussion. And at that point, you can also kind of raise your hand and ask a question if you want as well. As I said, we're recording this session just so you're both aware. Both the Climate Sustainability Team and the Institute for Artificial Intelligence here at King's host a range of events throughout the year and other kind of interdisciplinary seminars that seek to engage with some of these biggest topics in our respective fields. We'll share some links at the end of this session as well to kind of let you explore more events that we have. But just to say, this seminar series is linked to our KEATS Sustainability and Climate module. It's a fully co-created open access interdisciplinary module that you'll find on KEATS. It's open to staff and students, unfortunately only for people at King's at the moment. And it covers, the biggest topics in sustainability, from the kind of science behind climate change to food, to sustainable finance, to social justice. And we'll put the link in the chat now in case you haven't enrolled and would like to. And for today's seminar, I'm going to hand over to our chair, Dr. Georgia Pangiotti. Georgia is a lecturer in visualization in the Department of Informatics here at King's, and she's also currently working on a King's Climate and Sustainability funded project called Towards Greener AI, exploring the effect of carbon trackers in machine learning teams. I'll hand over to you, Georgia.
Thank you, Rosa. Hello, everyone, from me as well. It's a wonderful set of people we're going to hear from today. I think it's a great initiative that the AI Institute and the Institute of Sustainability are putting together. Okay, so I think the way we're going to do this is we're going to start with a few introductions from each of our speakers. They're going to briefly present themselves and present their work and their relationship between waste and AI. And then we're going to do like a Q&A format where I will kick off the discussion by asking a few questions to the participants, but then we hope that you will chime in as well. And we're going to try to make it as interactive as possible to get the most out of the perspectives from everyone. So without further ado, I would like to ask our speakers, our panelists, to briefly introduce themselves and their work in AI and waste. And I think, if I'm not mistaken, first one is Fuji Kojima. Yeah. Fuji.
Hello, guys.
Yeah.
Hi. Good evening. So actually, from Japan, so it's very midnight, and yeah, thank you very much for giving us this opportunity. So I'm CEO of the Perica. So Perica is a waste tech startup and based in Tokyo, Japan, and we are using AI for survey of litter distribution in Japan. And today we will introduce of that. Thanks. Okay, so So today I would like to talk about the social change using AI and its case study of litter problem in Japan. And so first let me share my personal story. So when I was 7, so when I was a kid, I read the books about environmental problem at the library of my primary school. And I thought, wow, it's huge, and I want to solve this problem. And solving this big problem would make me a big hero. So it was beginning of my journey. And at 23, so while I was in graduate school, I took a gap year and traveled to 18 countries. In each country, I saw so much waste leakage and it caused serious hazards for environmental situations. I noticed it was a serious global environmental problem, and I decided to solve this problem, went back to Japan and started the Perica project with my friends. Finally, I dropped out my graduate school and left my career as a researcher and established the company Perica in 2011. By the way, Perica means clean or beautiful in Japanese indigenous island language of Japan. So next slide, please. So today, I'm proud to say we are the world's leading startup dedicated to waste leakage area. So next, please. Yeah, thank you. So plastic pollution is a global challenge, including in the EU and also UK, and around 8.2 million tons of plastic waste is managed and discharged into the nature world in each year. So next, please. And we have developed innovative technologies for litter survey, collection, and recycling. We provided our services to many governments and companies. So next, please. So today, I'd like to introduce the Takanome innovative solution uses AI and smartphones to track litter distribution. By the way, Takanome means eagle eye in Japanese. So next slide, please. Oh. Yeah, it's it's user-friendly, so just attach a smartphone on the vehicle's dashboard or actually, so unfortunately, so there are no images, but so we can also using the Street View data like Google or Meta. And next slide, please. And the system identifies litter using AI. And next slide, please. And visualize litter distribution and helps NPOs and local governments to keep their city clean. So next slide, please. So in Japan, companies so like transport, waste, and logistics, and local governments are using Takanome. More than 1.6 million kilometers of roads have been surveyed for litter distribution so far. So there is no country in the world without roads. So therefore, so this method can be used as a universal method. So we are now extending this research network all over the world. So next slide, please. And we provide Takanome data for many Japanese local governments, and we create some use case for solving the plastic pollution. So one example is the reduction in illegal dumping patrol cost. So many countries hire people to conduct littering and illegal dumping patrol. So with Takanome, patrol can be carried out at a lower cost than in the past. So next slide, please. And in a study conducted in Japan, so it has been found that by carrying out cleanups in high litter areas based on the litter distribution data, so 3 times as much litter can be collected as usual. So next slide, please. So we want to expand and extend this initiative to the UK and the EU as a whole. So if you are interested in taking part in our volunteer research program on your own iPhone, so please contact us. Yeah, thank you very much.
Thank you. Chiara?
Hi, everyone. Thanks for inviting us to this seminar. Sorry, I turned off my camera because I'm afraid the connection is low for this part of the seminar. So I can share my screen with you. Show the presentation.
Yeah, I think we can see the slides already. Okay.
Yes. Can you see my screen?
Yes, we can.
Okay,
Go.
perfect. So hi, I'm Karen Curvaia. I work as carbon accounting specialist in Relearn, and my work is focusing on how technology, particularly AI, can drive more efficient waste management and reduce environmental impact. I try with my work read the gap between data analytics and actionable solution. So today I'm here to talk to you about Relearn and what we does today. So the world is facing a growing waste crisis with over 2 billion tons of only municipal solid waste generated annually. And as a consequence of global population growth and urbanization, waste production is expected to rise significantly, posing critical environmental and logistical challenges. In art today, most of the waste produced is still disposed to landfill and not recovered, resulting in a loss of its value and different environmental impacts. So this data underscores the urgent need for sustainable waste management practices and innovative technologies to address these escalating issues. So today, there is no standard tool for measuring waste production. The only way to get waste data is by weighing each waste bag. This process is time-consuming, expensive, and involves many stakeholders. As a result of this, a lot of organizations don't have accurate data about their waste production and don't know their impact. Moreover, the quality of waste sorting and recycling is not known. So how can we solve a problem that we can't measure? Our mission in Relearn is to nurture a conscious waste-free world by making data meet people. So Relearn developed Nando technology, the first waste monitoring solution. And our tool, one of our tools is Nando App. Nando App is a data-driven solution which monitors and measures the quality and the quantity of waste production. And thanks to AI, it recognizes every waste item sorted into the bins. How does our technologies work? It's very simple. You just need to frame the QR code linked with the station bins you want to monitor and take a picture inside. Our technology is based on image processing through the AI. So the first step is the recognition of the area occupied by waste. The second step is based on the visual separation of waste from the bin. So the volume occupied by the waste is related to the physical dimension of the bin, and through numerical density, the weight of the bag is obtained from the image. For the quality, to get data about quality, given the following images, the processing is based on detection of the object's percent, and the contaminants are highlighted considering the specific set disposal rules. Why is a data-driven solution? Because all collected data is presented on a dedicated dashboard aligned with the International Sustainability Framework standards, in which you can consult data with a specific period and space about total waste production, total waste generated, and an object analysis, recycling quality with a contamination analysis for each bin and space, and data related to the operation efficiency in terms of waste bag change, thanks to the filling level analysis. And also data on CO2 emissions to know the impact related to the quality and the quantity of waste production and the operation. Together with Nando App, we developed Nando Quiz, and with Nando Quiz also promote engagement and awareness of the community in some contexts, such as universities and offices. And we use gamification and rewards to promote proper waste collection and support also sustainability, sustainable business and eco-friendly habits. We work with different organizations from different sectors, and today I show you a case from Bocconi University. At Bocconi, we have activated the waste monitoring and also the engagement system. And in 1 year together, we managed to increase the quality of waste collection about 30%. We also raise awareness around 50 users and saving around 1 ton of CO2 emission thanks to good practice. In the graph above, you can see the correlation between monthly recycling quality and number of monthly interaction. So Nando can help organization in waste management achieving compliance with the international certification standard, promoting operation efficiency by optimization of the routes, reducing unnecessary transport, can help identify contamination that reduce treatment costs and also emissions, and saving times with automation of thanks to the automation of data. So we are growing. Today we are in 9 countries, and we help with more sustainable waste management. 45 organizations, and thanks for the attention.
Thank you. Thank you, Chiara. So now we have Professor Christer Holstrand.
Hello there, everyone. Yes, so I'm Christer Holstrand, and I'm head of Department of Analytical, Environmental and Forensic Sciences here at King's College London, and talk a little bit to you about the research that we're doing. Let me see if I can control this. It doesn't look like
I've given you control, Christer, but if it doesn't work, let me know and I can just click
I don't know
through.
why it doesn't work. Oh, did I do it?
I think you did.
Okay, so so when you are so waste is obviously generating chemicals in the environment, and the way that we need to know about how chemicals could affect ourselves, our health, and also the health of organisms living in the environment is to look at the risk that the chemicals have. And you do that by assessing the hazards, that is the intrinsic toxical properties of a chemical, and also the exposure that you're exposed to, because something might be extremely toxic, but you're never exposed to it, so it's not a problem. The problem, however, is that there are currently about 100,000 chemicals on the market. Of those chemicals, believe it or not, only 500 have been properly assessed for their intrinsic hazards, and about doesn't really want to work, and about 70,000 chemicals have really poor characterization of their hazards or the exposure that we might have from them. It doesn't want to listen to me. It's just very, very slow. Okay, so these chemicals end up in the environment, and maybe you can take control instead, please.
Yeah, no worries. I'll just stop sharing and then reshare, and hopefully that will kickstart it.
So these chemicals end up in the environment, and 70%, oh, no, yeah, one at a time. 70% of these, that's okay, don't worry about it. 70% of these have no or incomplete evaluation of their chemical properties or the toxicity that they have. For each of these chemicals, it takes between 6 and 20 years from innovation until they have been assessed for their safety. And that is usually done for human health concerns. It's usually done in rodents currently. But we know from pharmaceutical data that there's only about 43% concordance in the effects that you see on a rodent in those that you see in a human. So it is less than half of the answers that we get from rodents actually we can apply to human. So perhaps we can do something about that then, and perhaps we can use computer power to do it. Well, 0.043 is the clock rate of the computer that took the Apollo up to the moon. A regular PC these days, like an i5, which is a rather modest processor, has 121,000-fold power of that computer. So perhaps we can harness that to do something useful in this space. Next. Next slide, please. So the problem then with traditional animal testing of chemicals is that we simply have too many chemicals to test. Click. And it takes too long time to test them, and it's way too expensive. For example, to test one single chemical for its safety to the environment costs £1 million. Next, click. And also people are starting to question the ethics of conducting animal testing. So, and in addition to that, rodents obviously are not people, despite what Walt Disney might think about that. So next slide, please. So we're thinking that just observing effects in rodents is not only has a poor translatability over to humans, but also gives us a poor mechanistic understanding on why these chemicals are bad for us. So we have a poor predictive power when it comes to generating new chemicals, and way too many times we have found that a chemical is not good for us, and we replace it with another one that is even worse. So what if you could spot these problems before they happen then? Next slide. So traditionally, the way that chemical risk assessment has been carried out is that you do these studies in rodents, and you look in different organ systems, and then you are having different doses of your chemical, and you look at different effects. Could be reproductive effects, could be behavioral effects, and so forth. And you establish the highest dose that does not have any effect. We call that an NOAEL. And from that, we set a safe exposure level, and we compare that with what people are exposed to, and we get a risk characterization. Is this going to be a problem or not? So next slide, please. So what we are proposing instead is to, instead of doing the animal experiments, that we are substituting that with clever AI solutions that will predict based on the chemical structure and the proteins that they're affecting what the effects would be, and from there then generate a safe exposure level and continue as we've done before traditionally. Next slide, please. So we're predicting the safe levels from a chemical. So basically what we are doing in my lab is that we are treating chemicals like people, and we are putting them into social networks. And that means that you can put attributes to the chemicals that we know from existing chemicals, and we can put all the knowledge that we have about each chemicals. And of course, social networks are really, really good at this. And by doing that, we can place each chemical within a social media space of having a certain behavior. And we can do that for neurotoxicity, for reproductive toxicity, for mutagenicity, and so forth, and predict not only what the effects will be, but also what the concentrate or doses that the doses of these chemicals that would give you those effects. So final slide, please. So we've done that for many endpoints. Perhaps we've been most successful in looking at mutagenicity, which is chemicals that interact with our DNA and downstream causing us cancer. And we can predict now with 80% accuracy if any chemical at all will interact with DNA and therefore have a potential to cause cancer. So that's my presentation. Thank you very much.
Thank you. Fascinating. And now we have, last but not least, Dr. Gabby Samuel.
Thanks so much, Georgia, and you'll have control of my slides. And I'm so sorry, guys, that I have my camera off. Let me know if my signal drops out. I'm calling in from Malaysia, so it's the second person that's not in the UK. So I'm a lecturer in the Department of Global Health and Social Medicine here at King's College London. My expertise is in ethics and sociology, and much of my attention is focused on thinking about the environmental harms that are associated with digital technologies such as AI, and how we can use these technologies in a way that is considerate of these harms. So different to what we've heard in the previous presentations. So much of my work uses qualitative methods. So I spend time speaking to people and conducting interviews and/or like group discussions with people. And those people are either professional interest holders or members of the public. And then I analyze and reflect on what these individuals tell me in the context of either ethics literature or sociological literature. So in my 5 minutes today, I wanted to bring this different perspective of waste that we haven't heard about so far in the discussion. And that's the waste that's associated with AI. And I think especially over the last few years, and as shown by the poll that was done at the beginning of this seminar, there's been this increasing societal awareness that's associated with the environmental harms associated with AI and how that relates to waste. But I really wanted to just reflect on them and give them cause for concern through my introduction now, especially for those that might not have thought about them in detail. And for those of you that haven't, but also for those of you that have thought about it in detail, we often hear, digital technologies described using metaphors such as connecting, in inverted commas, virtually, computing in a cloud, or streaming, in inverted commas, programs. And these all suggest that the digital world is dematerialized, somewhere out there where we can't really tangibly hold it. Can we move the slide, please? And again, sorry. So as you can see from this diagram, AI and its underpinning digital infrastructure, which includes, large amounts of data storing and processing, has physicality. And these colossal amounts of data are housed in data centers, which you can see in the right and bottom left, which are basically just massive factories of computers joined up with cables. So the bottom right, they're undersea cables that connect our world digitally. And digital data centers are expanding at such a rate that we're starting to see moratoriums being put in place. So there's now a moratorium in the Dublin area in Ireland until at least 2028 for any new data centers to be built. And that's not for environmental issues. That's just because they're sapping so much of the electrical grid. But in the Netherlands, they've imposed strict regulations on hyperscalers from developing. And a hyperscaler is a really massive data center. An example is in the bottom left. And interestingly, amongst all of this, the UK has recently announced that UK data centers are now designated as critical infrastructure, which comes along with all the protections that are associated with this. So there's quite a lot of interesting tensions in this space. Next slide, please. So the computers housed in these data centers are manufactured from minerals, which are often scarce minerals, and they're mined, and this mining often produces a huge amount of waste, as you can see from this slide. And this is especially the case when the mining is conducted through extractivist practices. So mining isn't necessarily problematic morally. It's the way in which we conduct mining that is more often the case, which is more problematic. And then beyond mining, when we conduct the manufacturing processes towards computers, this also raises huge amounts of waste. And there's been like a huge number of environmental justice and social scholars that have documented the health harms associated with working at manufacturing sites, with the waste produced from manufacturing processes like having long been shown to lead to various forms of cancer, miscarriages, sickness, and even death. And such waste is also leaked more broadly into the environment, where it causes extensive environmental harms to the planet and those who live in it. Next slide, please. So a significant portion of global e-waste or electronic waste also comprises digital technologies. So now I'm moving down the supply chain, right, from mining to manufacturing, its use, which we know is associated with carbon emissions, right through to the waste. And especially things like circuit boards and other digital technologies, they contain a whole variety of hazardous materials, lead, cadmium, mercury, nickel, and these are a major challenge for disposal. They're not easy to be recycled. And there's a lack of regulation in this space, which means that only about 1/5 of e-wastes are formally collected and recycled globally, and the rest are most likely dumped on landfills or traded through illegal markets. And in fact, e-waste often moves in streams from high-income countries to low and middle-income countries, where it's left in huge dump sites, as you can see in these pictures, either immediately or after being recycled, reused, or refurbished. And now these e-waste sites pollute the environment, and at the same time they're a source of livelihood and business opportunities. So you have like quite a lot of tensions emerging because it's seen as an asset for the people that work at these sites. But the issue is that they're working in unregulated conditions with informal methods, as you can see from the picture. So open burning, incineration, acid stripping of metals, and acid baths. And this generates hazardous byproducts that have been shown to be present at increased levels in those living around informal e-waste sites. And chemicals in their bodies have been shown to be hundreds of times over the tolerable daily intakes, posing not only serious environmental issues, but also health issues. Next slide, please. So sorry? I think that someone hasn't turned off mute. So that we designed this postcard. It's fictional, just to kind of give a flavour of the issues that are associated with e-waste. So here in Sri Lanka, almost 50,000 people, including young children, desperately stave off poverty, selling the precious metals they've recovered from TVs, phones, laptops, and other discarded electronic devices, exposing themselves to highly toxic chemicals in the process. Apart from the awful and hazardous conditions, this graveyard for unwanted equipment is also a terrible monument to the carbon emissions tied to making, using, and then replacing our gadgets. Globally, e-waste will contribute to the equivalent of 8.5 million metric tons of carbon dioxide by 2030. Probably worth remembering the next time you want to upgrade your mobile. Now, while worrisome, and I don't want to take away from these harms, and something that must be addressed, there's been some really interesting anthropological work that's emerging in this area that questions the framing of e-waste by foregrounding pollution and environmental health risks and foregrounding regulation as a magic solution to the issue. And some of this work has been conducted in India, where the implementation of regulation has caused some real problems with the current informal recycling sector. And I'm happy to talk about that more if anyone's got questions. And then there's other anthropological work in both Africa and India, which expose these e-waste dump sites as more than discarded place of trash with a high environmental cost, but as lively areas of activity where individuals and communities come together to live and work, form friendships, and build relationships. And while the context of the Indian and African anthropological studies differ, what's similar to both is the means that for the people that live in these communities, and in comparison to what we see in the NGO and WHO reports, the overarching long-term health and environmental risks are not a driving concern, but rather access to e-waste is a key priority. And I can talk about that more, but what I wanted to leave you with is that these places, these e-waste places, may be so much more than these victims of environmental harm, but they're where issues of coloniality, extractivism, and capitalism come together with an environmentalism of the rich and the need for sustainability. I'll finish there.
Thank you. Great. These were really thought-provoking talks, I think. It was great to have perspectives both from the industry and from academia and from both sides of the problem, as seeing like AI as a wasteful in itself, or AI as a means to kind of tackle waste that we have other types of waste. So I wanted to start with a question, like a little bit like more fundamental, like a bit more broad question, like what are the biggest challenges in waste management today? And more importantly, it's like, how is AI uniquely positioned to address this? What has it enabled that wasn't possible before? Like, and I wanted to start with Fuji on this, because I heard that your company is quite many years old, right? So you saw the transition into AI, and I was wondering, like, what did it really enable? How did it change your practices or your perspectives? Yeah.
Okay, so thank you. So now we are focusing on the survey of plastic litter distribution, and so we're still focusing on this problem. But what humanity should be working on using the power of AI is to find ways to break down waste that is difficult to dispose of. So for example, so plastic or so sometimes nuclear waste, so there are so many kinds of waste that is difficult to dispose of, So finding the way to break down is a very important challenge for the human race, I think.
Great. Somebody want to jump in on this? Like, how has maybe Christer, how has AI kind of changed your research or your research approach to understanding chemicals, for instance?
Well, I mean, we used to run animal experiments, and then that was clear that it was more difficult to do that, which actually was one of the drivers why we started with AI, and there was a long actually discussion of doing this for a couple of years when we contemplated it, not really having the computer science background from the beginning, and then finally we just grabbed the courage to do it, and it has been an enormous, I think, progress and advancement in very, very short time in that space. So yeah, so it's been for us, it's been a game changer. The problem in doing what we are doing is that so if we are trying to tell the public that something is either is bad for you, then the manufacturers or chemical industry, whoever has to clean up, are challenging that and saying that, well, how do you know that? And likewise, if we are saying that something isn't harmful, then we have public coming back and saying that, well, how do you know that? So you have both sides of the coin always being challenged. And the problem with AI is that it often is a little bit of a black box, because it makes up its own mind, right? You don't really know how the algorithms work, but the beauty of it is that it really does make up its own mind, and it's sometimes difficult to explain or answer just that question. So to address that, we are going to feel that we're starting to do explainable AI. We now are specifically asking, like, okay, so you're saying that this is not good for us. Why is it not good for us? And you then get certain indicators of why that will be the case, certain structures, certain groups, and things and the relationship to other chemicals that have been proven bad to us. So it is doable, but it's not that is a challenge that we are facing.
Yeah, definitely. I can imagine. I think there's a bit of an echo somewhere. Yeah, I can imagine that the explainability dimension is actually something very relevant, right? Because you have to go from experiments with animals, right, that give you kind of concrete results, and now you have to more stochastic processes that you just get like probabilities of something being right or wrong in a way, right?
Yes, exactly. Yeah.
What about Chiara? How has it been in Relearn? How were you a company before the AI Boost? Was it something that you were inspired by and used, or how was this switch for you?
Yes, we noticed this problem also in Relearn. I think we think that AI can be a solution to take environmental challenges, not only for optimizing waste management, but also for example, monitoring ecosystem, the energy efficiency, or reducing carbon footprint. So I think we can know there are examples about it. So for example, Smart Bin equipped with AI sensor notify collection services when they are full, optimizing collection routes and minimizing the use. Or for the monitoring of the ecosystem, there is a platform like Global Forest Watch use AI to detect forest loss in near real time, enabling faster intervention. And other for the energy efficiency, AI-driven system in wind and solar farms adjust operation dynamically based on the weather forecast, increasing energy output. So I think there is also a solution. So.
Yeah, I wonder actually to follow up on this, Chiara. Like, I'm really curious actually for all of you. Like, how do you quantify the impact, the environmental, let's say, good that you're doing with your solutions? Like, what kind of metrics do you use, and how can they be kind of let's say contradicted with what Gabriel is talking about, like with the environmental impact that using AI has, for instance? Have you come across that at all in your work? Is that something you're considering at all?
I think
I'm sorry.
For us, the most obvious difference is the and what we get asked a lot about is how many animals that we save, and because people really have started to not like that animals are being poisoned to death by chemicals that we are using for our perhaps convenience. So that is a very clear benefit that you can point out, that you no longer need to do this. We can do this instead.
It's a very clear indicator, right, and a very powerful one. Do you consider at all so far like the impact, like the environmental impact of using such models, just to bring in Gabriel's perspective a bit?
I think you have to see it from the background where I started, where you have 70% of, and so we have 100,000 chemicals on the market today, but there's much more chemicals in the environment. There's probably something like 400,000, depending on which way you're looking at. And again, 70% of those have never been tested. So at least we are offering some means of testing them, and some means to get an indication of where do we need to focus our attention to perhaps clean up or avoid foods for if it comes to humans for that contain certain types of chemicals. So we actually are, I can't say too much about it, but we actually are getting into using these models within not legislative, but in agencies that are involved in risk assessment. So it's actually coming to real world use.
Okay, exciting. We have a question in the chat. That's great. Maybe if somebody else wants to chime in, like, I don't know, Gabby, did you have something to bring in terms of like the effect or the quantification, let's say, of this effect? the
Well,
measurement?
I was just really interested in this work you're doing that saves animals, which I think is absolutely fantastic. Although I'm sure that some of the chemicals that you'll be testing are potentially the ones that are used during the manufacture of digital technologies, right? So it's like a circular solution. But I think it's important that while there are a lot of environmental harms that are generated from AI, like not that we don't put too much responsibility on, researchers to necessarily have to address all of them. I mean, I think there's a question to be had. It's not like every person that is conducting research with AI should be, or there's a question, should they be thinking about these environmental harms, or should these environmental harms should they be reflected at a much higher level? And what does it mean to have responsibility or not have responsibility or agency around these questions? So I think there's a lot of ethical debate that needs to be had there, I think.
Agree with that.
Tiara, Fuji, anything to bring in from the industry perspective on this? Like, how do you quantify the effect? How do you go to your clients or your sponsors or your investors and say, look, we're using AI and we're, I don't know, saving the environment? What kind of metrics do you?
From the entrepreneur side, so all we have to do is just try. So using our brain and also using AI and just try and try and try and try. So we have easy to use AI resource and easy to use my brain as well. So just test and watch result and to just make decision. So it's not so difficult problem for me.
Chiara, did you want to jump in, or should we ask the questions from the audience?
Can I just jump in?
Sure.
And I just want to add that I think it's fantastic that we're developing, these tools, these AI stuff that I'm certainly not clever enough to develop myself. But I don't think we should ignore the fact that we should reduce consumption, right? Rather than trying to develop technological tools or complementary maybe to developing technological tools to address issues of waste. Let's try and deal with the problem rather than sticking a band-aid on it and think, okay, shall we try and reduce consumption? So I just wanted to kind of raise that. I'm sure you guys have a lot to say about that as well.
That's an extremely good point.
Yeah, there's actually a very good follow-up question from the audience, which I think fits perfectly with what you're saying. The question is, how can we determine which problems are best addressed with AI and which problems can be better tackled using social change, enterprise, best professional practice, or change in regulation? So how do you decide these things? Which ones are best addressed with AI and which ones are, let's say, more fundamental societal ones?
One conundrum that, oh, sorry, go ahead, Gabrielle.
I was going to be very quick and then I'll pass straight over to you. I was just going to say you speak to people on the ground, right? Instead of doing like technology push, you do technology pull. You go and say to people, what is it that you need? And then you think about the options of addressing those needs based on their values rather than trying to put your own values and needs onto a problem. So I think that's one very good way through community engagement. Sorry, straight over to you. Sorry.
Well, that was really important. One conundrum that we have, I think whatever space that we're working within is that where we need solutions is where we have least knowledge. But AI is very information hungry. So you need large training sets in most cases so you train an AI, you tell an AI that this is what this looks like. This is what this looks like, be it a face or be it a chemical or be it a piece of waste. But if you don't, so where we need it most is where we don't have a lot of information already. But because you need that amount of information to train it, it is the most difficult place to actually use it because you don't have the training sets. So that is There are solutions to that. You can do transfer learning, so you can teach on something that isn't your problem, but it's related to your problem. So, for instance, you could teach an AI to recognize faces by showing it cat's faces or dog faces, and it will probably figure out that, okay, so that is a face, and we can then recognize human faces for that. That's just an example. There's not directly transferable, of course, but that's generally the problem, that AI is data hungry, and we need AI most, but we don't have any information.
Picking up a little bit on this idea of, let's say, value-driven understanding of, I'm going to come back to what you said, Krista, as well. I'm just trying to synthesize something here, half-baked. So thinking that you guys have startups, right? Both Chiara and Fuji. How much did you involve end users in your, because you also have tools that are meant to be used by end users, right? Like common folk, like not necessarily experts. So how do you involve them in this process, and how do you see the response from them, right? In terms of their appreciation for doing something like this? Is it something that is needed? Is it something that they see that would be something different? How do you see that? Chiara, do you want to start maybe?
Yes. Yes, it's a good question, because the engagement is very hard, because especially in areas and contexts like university, where different people pass every day, but there are two main things that we use. For example, the gamification features for the recycling challenge. With the recycling challenges, students could compete individual or in teams to see who recycles the most or sorts waste most accurately, or with a reward system and a sustainable incentive. These students earn points for correctly sorting waste, redeemable for rewards like a discount at campus cafes, reusable water bottles, or voucher for eco-friendly product, for example. And they can give us instant feedback on the service and on the accuracy of AI recognition of the waste and the regulation that are talking about.
Okay, so let me share our case. So at the beginning, so we need to involve the truck drivers, so for getting many data from the vehicle. But most of the case, truck drivers don't want to use AI or very new technology, and we just explain our product. No, it's not AI. It's just iPhone. It's kind of like just driving recorder or dash cam, and just put it and yeah, support us. And so we explain what we are doing and how we can clean up the city or road, and yeah, so they can contribute our project. And so finally, so some drivers and some companies could support us and so make good decision. And yeah, so at the beginning, so we did like that. And second big involving is, yeah, we need to use our data, so created by AI, and try to make a good change, so to clean up the city, But so in this case, so no one knows so how to use the new data to keep clean the city. So that is why, so at the beginning, so we have to show by ourselves. So what we did is, so using the litter distribution map, and so we separate my company's members 2 teams, and 1 team using the litter distribution map and clean up the city, and another team didn't use the litter distribution map and just clean up the city. And we show this experiment for the government people or citizens and many organizations. And finally, so the result is, so the team, they using the data can pick up 3 times waste compared with the team don't use the data. So finally, so the result can explain our data productivities, and so many government and the organization could use the data. So it's a very, very small steps and very tired steps, but I think so we need these kind of steps.
Yeah, definitely. It seems like after you deploy it anyway, that's when the value kind of comes through, right? It might be, I mean, there's this idea in design, at least, that the users necessarily don't know what they want or what they need. So to an extent, let's say there can be limitations in asking people on the ground on what kind of solutions would you want as well. But I see Krista has a hand, and then we have also a question.
Yeah, just short question to Fuju. So Fuju, you're saying that the truck drivers aren't really happy when you're saying that it's AI. Do they think that it's spying on them, or that it's taking information about what they're doing? Do you think the truck drivers who are suspicious about using AI are suspicious because they think that your algorithms are taking information about them, where they are and what they're doing and what they're saying? And
in my experience, so they don't care so about the detail of AI. So they just care for the camera, so not so record the inside of the car, you know. So they just want to, they are private. How to say? They just want to protect their private, and they don't care about the, how to say, so our AI's technology or potential or something like that, you know.
Great. So I see another question here, which is specifically for Chiara. What are the biggest challenges with students and staff engagement in the universities within Ando App and of disposing waste better?
Okay, sorry, but I have some problem with connection. Okay. Yes. No.
Do you want me to repeat the question? Or is the connection? No worry, maybe I can go to the next question and I can come back to you. That's fine. So this is for Krister, and it says like, has Krister gotten to a point where you are able to use the models to identify new studies or design of experiments that generate results that maximize understanding for the damage of wider groups of chemicals beyond those immediately studied? And if so, do you have any high-level learnings about how well this works in practice?
Oh my God, I'm not even sure I understood the question.
I think the question is like, have you
I can explain it if you like.
Yes,
Yeah,
please.
thank you.
Yeah, so imagine you've trained your model for the toxicity of products. You've got
Yeah.
parts of space that have relatively low amounts of information.
Yeah.
Have you got models to then suggest where if you have a set amount of funding per year to generate new data, where it would be best to study a certain compound because it would maximize information in that area of kind of learning space where there's not much information at the moment.
Yeah, so that is an interesting problem. So so if you imagine, so chemical space is not uniformly. So if you try to train and I can hear that you understand what you're talking about. If you're training an AI on something, then you present them with something that it knows as being a good sample of the universe. But chemical universe is not evenly distributed. It is very well expanded in certain areas, but not so well in other areas. So so you get an uneven distribution of molecules that it can compare to. So we actually have another project where we are trying to address that and other issues by generating the chemical universe. So we're talking about generating 9 trillion molecules in silico to make it known to the AI when we're then trying to use it to train models. So yeah, so that is and the idea of that is also to be able to identify in which parts of chemical space that you have both where you have chemical applicability in terms of drugs, for example, and also in terms of chemical space that you probably don't want to mess around with because they're intrinsically bad chemicals, and which is essentially what people actually have been doing for a long time when they in what I touched upon previously with poor substitutions or undesirable substitutions. So you have a problem with one chemical and it changes a little bit and you get another chemical that essentially looks like the first one and it keeps on having the same problem, only that you didn't know it a priori although you could guess it, and they keep on doing that. I think the best example for that is probably with flame retardants, where you started with the PCBs, which turned out to be a terrible thing for the environment, and we've known that since the 50s. And then we are gradually gone over to chemicals that actually look the same, but they are just substituted with different halides instead of the chlorine. Now they're using bromine and fluorine, for example, and but otherwise they look the same. And so that's the other part of it, which I think also possibly addresses what Gabrielle was saying before in that with consumerism, in that if you could educate inventors, or if you could give a tool to inventors to tell them that what is likely to be good and what is likely not to be good before they started to create lead compounds or potential chemicals that could have potential use, then I think you've gone a very long way, and you saved companies' monies by not going down the wrong paths, and you saved the environment and you saved human health as well. So yes, Ethan, it's very non-circularly distributed, and the chemical universe, and that does create problems. So we have like black holes where we don't know what things look like yet. Does that answer your question?
Sorry, I'm just eating there. Yes, it does.
Thank you.
Can I? Yeah, go on.
I was just going to jump in and say I don't think it's quite as simple as if we can educate. I mean, I agree with everything, but we can educate inventors and then the problem will be solved. This is a social political issue. There are many chemicals out there that we know are very bad, but we'll use them anyway. And even after, say, the Montreal Protocol, there was a shift to some compounds that we knew had a climate issue, but because they dealt with the ozone issue, which was more pressing issue, they used them anyway. And so there's there's a question. It's a social political question. Which chemicals are we going to use and which ones not? So we do need the science. So we do need the kind of work that you're doing and the in silico models to, give us data, and also data to hold companies attributable as well, right? So that you can kind of link causes as well. But we mustn't forget the socio-political aspects of which chemicals come into play and which ones don't.
You're absolutely right about that, and there's a global aspect of that also. I think definitely companies have profits to think about and are very concerned about their profits, but they can be held more accountable if something does happen and they could prevent it from the very start. Then it's an accountability issue that they perhaps don't have at the same degree, because all they need to do now is to say that we made this new chemical. We don't think that it's going to create any harm. Can we use it, please? But of course you're right, and it's DDT is still used in regions like where you are now, Gabrielle, because it's so effective in doing what it's doing, and it's cheap, and people don't care about the environment if they can save their own lives.
Exactly, right?
Yeah.
Okay, I'm gonna bring it a little bit back to talk about AI, and I wanted to ask Gabrielle this. It's a question that's been upvoted a bit as well. It's like, how do you balance the emissions being produced by AI with the positive impact you can have by using it? So how do you make these kinds of trade-offs? How do you come to these kind of decisions?
Balance is very hard, and trying to move away from the word trade-offs, because it suggests that you have to give up some of the goods or to get rid of the bad, right? It's one or the other, and I don't think it needs to be one or the other. It's just one or the other in the kind of socio-political context that we live in. But what we need to move to is being able to use AI for good, however we define good, and that's an ethical conundrum, but in a way that is considerate of those environmental harms as well. And so I suppose the type of work that I've been thinking about in terms of how to balance is questions around responsibilities, which is what I was talking about earlier, right? So we need to think about these environmental issues, and we need to think about them early in the process. So as soon as we're starting to use AI, how are we storing our data? Excuse me. What kind of energy harms are we thinking about? What are we developing? Who can use that? Can it be reused? And then thinking about all the infrastructure along the way. But making sure that that's done right at the beginning through a precautionary approach. And all too often, we're not using a precautionary approach in AI. We're just grabbing it and using it without that consideration. But the issue with that is that the people, like the researchers like you guys or the startups like you guys, can't solve all those issues if you're on your own. You can't suddenly develop this infrastructure if you want to use AI around e-waste, because it just doesn't exist. So then you have this mismatch between what you want to do at this level is you want to produce AI for good. You want to think about your environmental responsibilities while using it in this good way to address waste, but actually you don't have the agency to do that. So it comes a question of what can you do or what should you do? It becomes an ethical question. And I suppose a lot of my research is around arguing that maybe it's more about like advocacy, or just asking the right questions to raise awareness is potentially all that we can do at our level. So I'm thinking of you, Krista, as like a researcher and using AI, but also like startups as well. Like if you're using a data company, asking those questions about social justice, asking those questions about environmental justice, because ultimately the harms are bigger than us, and we need the technology companies on board. And the only way that we're going to get them on board in the environment that we live in is by that consumer pressure, by asking those questions and trying to drive change. So I think I strayed off on one about balance, but I think the most important thing is not to see it as a trade-off, but to see it as developing AI in a way that considers its harms to mitigate them as much as possible, whilst also doing good.
So what is the role of regulation in this balance then? Like, because you mentioned it before, right? You mentioned that it's been brought in as a panacea, right? That it's been brought in as a solution to everything, but you don't believe necessarily that it's the case.
Yes. I do believe in regulation. I'm, very pro regulation, but what I'm against is what you could call regulatory solutionism. So the idea that we just say, well, we've got regulation, so problem solved. So to give you a quick example, there's this ethnographer, anthropological guy, I can't remember his first name, Smith. He wrote a book called Eyes of the World. He was looking at conflict minerals. And he was arguing basically that the regulation is brought in to address the use of conflict minerals, helped us in the West feel very morally light, right? Because now we're buying or getting our minerals from non-conflict zones. But actually, he did a lot of anthropological work to explore how that regulation actually really infected those artisan miners, the people on the ground and the problems that it caused. And similarly, we've done a project on e-waste, and lots of anthropologists have done some projects on e-waste in India. And India had this thriving informal sector on e-waste. There were lots of environmental hazards and lots of health hazards, but they've brought in regulation, and they've taken that regulation from Europe. It's quite a colonial bringing in of this regulation to formalize the waste sector that was already there. And there's been a huge, I suppose, tension between formal and informal sector there that has led to a whole multitude of problems and trying to work around the formalization and leaving people, without money and pushing them into neoliberal contexts and so forth. So I'm not saying regulation is a bad thing. I'm not saying we shouldn't formalize issues, but if you go and speak to e-waste workers and you say to them, what are your concerns? They'll say things like that I've got enough waste so that I can make money. Or, it's not about the environmental harms that are going to affect me in 10 years, but it's this burn or scar on my hand right now. So I think we need to, and that's what I meant about going and speaking to the community. What are the issues that they're facing? And let's be careful not to put our own ideas onto their own needs and their own values. So I think that's what I meant by regulation.
Great. Yeah, I think that totally makes sense. Like it's a different kind of regulation, right? And each context is different. Each country is different, and we need to kind of respect that. I have one question that I think kind of can I would like everybody to kind of take a stab at, if possible. So, and it's more of like how do we kind of summarize this? Like, what would you suggest? And I think Gabriel has talked a little bit about this already. It's like, given the environmental impacts of AI, but also its potential for waste, like what should consumers consider when deciding to use it? So how can we as consumers make a difference when it comes to environmental and social impact in these cases? So I know that each of you have a different perspective, like on how we can support this, but what would you suggest for consumers? Yeah.
I can go first if you want, for the silence. Let's not responsibilize the consumer for issues that need to be dealt with at a much higher level. So that doesn't mean consumers don't have any responsibility. I'm just saying, let's not put it always on the consumer. Let's be very careful not to individualize this problem that is a social-political problem that does need, here you go, regulation, right? We do need some regulation of big tech, of all of these issues, of, for example, the chemicals that are used during the processes of manufacturing. But if I, as a consumer myself, asking questions, always asking questions, advocacy, trying to use phones for as long, like in your computers and gadgets for as long as possible. So it's like reducing consumption as much as possible and trying to use circular economy as much as you possibly can, knowing that that is not a solution, knowing that there are problems with that processes and that you still need to advocate for other things, even though, it's not like I've dropped my thing in the recycling bin, I'm morally light. We know recycling infrastructure is absolutely rubbish, and the thing I'm putting in my recycling bin isn't actually probably going to be recycled. But I do that. But then I also ask questions and try and create awareness and do other things. So that, I suppose, that's my view of it. But again, it comes back to what Donna Haraway says as responsibility, right? You can't have responsibility if you don't have the ability to respond. So responsibility can only be at the level that you have the ability to do anything.
Beautiful. Hard to to follow up on that? Anybody?
I thought it was a really good answer, actually.
Yeah. What about from the perspectives of Chiara and Fuji? Like, I don't know, do these things kind of resonate to you? Is it different as a startup? Does it, because I understand sometimes, because I'm also a researcher, right? So it's easy for me to be very much like in a way, almost like in a moral kind of have an opinion, very strong opinion about things, a very critical opinion about things. But how does that translate into industry, right? How does that translate into a startup? Can you afford this kind of reflection, let's say, or is that something that is reserved for us?
Okay. But for example, yeah, we think about it in real world, and about also what should consumer consider, and maybe there are three main factors, I think, when engaging with AI. The first one is to opt for an AI-powered products or services that prioritize energy efficient operations, maybe, or are powered by renewable energy sources, and it's so difficult, I know. Or be mindful of the life cycle of AI-enabled devices, probably recycle electronic to reduce waste and support companies with stronger sustainability initiatives. Or choose brands that are transparent about also the AI system, and yeah, or push for greater transparency and sustainability in AI, also supporting companies with strong environmental and ethical commitments also in this sector, I think.
Great. So it seems like you are actually actively kind of working on this topic and considering it in your how do you say, your company environment in a way, right?
Yeah.
And what about you, Fuji?
So my opinion is, yeah, as a consumer, so yeah, AI is very important, and but so what we should do is, I think, not consider, so just practice. So because no one can escape from the AI power, and it's very difficult to consider about how to use AI or how to use the data like that. And but so, and we also have to how to say, we need the help the AI to consider to use AI, and yeah, so that is why. So what we should do is just practice and using data, and so make a good decision with AI, I think. And but on the other hand, so now AI is now improve day by day and year by year and very rapidly. But the physical robot or machine is more slower than the AI improving speed. So that is why. So what we should do is just do the good things that AI still cannot do. So like pick up litter or clean the city like that, because so we can't wait the improving the robot or AI until the environmental crisis will more really worse situation, So that is why. So now, the human have a good body and a good brain, and so yeah, we have to start good action from today or to tomorrow. It's a very, very important thing, I think.
Yeah, so if I understand correctly, like you believe that that AI will actually kind of balance out, like the fact that we're using it, there's a whole kind of chain of thought of like quite a few people are believe that with given the enough advancement of AI, then we can actually kind of improve its environmental impact rather than seeing it as a problem necessarily, something like that.
Yeah, thank you for translate. Yeah.
No, I'm trying to summarize in my head. Okay, I think we have time for like the last two questions here. It's been a really rich conversation. So these are actually related to what the future. So what future advancements do you see shaping the future of waste management in the next decade? So what are we expecting to be the next big thing? So I see that both of you, at least in the Chiara and Fuji, you work with computer vision. Are you excited for something new for the potential of waste management coming up technologically?
Okay. Yeah. So let me share my image or vision. So now AI expanding and so improving day by day and so fast speed. And so maybe next is the robot or so physical machine will improve. And so maybe Tesla or some big company create the humanoid robot in maybe next 2 or 3 years. And yeah, so we can physically create the good impact for environmental crisis or environmental problems. So it is how to say, it's a competition between the create the solution and to destroy the environment problem, So that is why we have to focusing on how to create the good things and how to create the solution. Yeah, that is a very interesting challenge, and I want to focusing on that. Yeah, thank you.
Great. The robots, I'm looking forward to seeing them. Okay, so maybe Chiara, if you have like something to say on that, what is the big thing you're expecting advancements in AI?
Yeah, I think AI can change the waste management in the coming decade, addressing inefficiency and promoting sustainable practice. And the key advancement include, for example, waste monitoring and predictive analytics for waste trend. It will analyze data from the IoT device and historical patterns to predict the waste generation trends, for example, or optimize waste collection routes in real time based on bin fill levels, traffic, and weather condition also. Yeah. And also can identify all the non-recycled material for energy recovery and enhance efficiency in waste to energy plants, for example. Yeah.
Sounds like you're on the right track then. If that's how you see the future, it feels like your companies are right on the spot. Great. Yeah, please, Christer, some closing remarks. I wanted to ask anybody if has anyone closing remarks. Yeah.
Sorry. So that is really not my field. However, I was given the task to write a piece about this together with the inventor of green chemistry, actually, and some people in the waste business. And I think back then, it's probably like 5-6 years ago now we did this. And back then it seemed like the biggest hurdle in recycling, and we're talking about that before, how little is actually of what is recycled actually goes back in, is how much you're duping the chemicals you are using for your materials with things like dyes and plasticizers and things, which makes the material unusable or at least very, very difficult to use it for other purposes. So, but there are technologies to create, or for dice, for example. I know Lego is using them. They're having dice that you can treats that basically disappear, and you can then recycle the pieces afterwards, and which was a response from very bad publicity that they had, that they used cadmium as a dye, which is not great for a children's toy really. But yeah, so there are solutions like that are coming up, and they're probably not cheaper than others, but we need to try to embrace them, and regulation is probably a part of that, but responsible people is also needed. Thanks. That's my concluding remarks.
Great. So I realize yeah, please, Gabby.
I was just going to finish with one sentence, which is, for every solution, we must constantly evaluate once it's been put into place. Okay, there are always unintended consequences to the solutions that we think are going to change the world, and inevitably people are always harmed. They might not be us, but there's always people. So it's very important that we can consider that when we're thinking about solutions.
I think that's a beautiful closing remark. I want to give the floor back to Catherine and Rosa. Thank you so much for hosting this. There was I think, a really rich discussion with multiple perspectives from different fields. Yeah, so I'd like to thank the audience as well.
Brilliant, thanks, Georgia. And yeah, hopefully everyone in the audience will join me in sending a kind of virtual round of applause to our speakers and to Georgia for really ably chairing that discussion. So thank you very much to our speakers, and especially those who are joining from a different time zone as well. I really appreciate it. So I'm Catherine, I'm from the King's Institute for AI, and just to say before everyone goes, we're going to share a few links in the chat in case you're interested in future events that the Institute for AI or King's Climate and Sustainability are running, and we're also going to share a link to a feedback form, and we'd really appreciate kind of hearing what you think about these events, so they kind of shape our future events as we look to plan those. But yeah, if everyone could just join me in one final sort of virtual round of applause to our speakers, and thank you again to everyone for joining.